So in our last session, we explored how we describe matter. And the word that we used for those terms that we use to describe matter is properties. And we said there are physical properties such as appearance, flexibility, conductivity. And these terms described what it looks like, its texture, its color, whether or not it conducts electricity or heat, whether you can smash it flat. We also describe some chemical properties, which is how it reacts. And a good example, of course, is throwing a penny into different kinds of acid. And it, of course, reacts violently with nitric acid, but doesn't react at all with the sulfuric acid. And today, what we want to ask is, what happens when we combine substances with different properties? Now, we're not talking about, reactions. We're not discussing reactions yet. And that'll be something that we will discuss at another point. But today, we're just going to be looking at a relationship between substances with different properties and what happens when we combine them. So welcome to Pure Substances, Mixtures, and Compounds. So let's start off with what we're going to call a pure substance. And according to the Googles, pure substance is a sample of matter with both definite and constant composition. And look at this, distinct chemical properties. So we're going to break this down into two groups. Elements versus compounds. Let's start off with elements. An element, according to the interwebs, is a substance that cannot be broken down into any other substance. Every element is made up of its own type of atom, whatever. You guys can read this. Here's what we're talking about. Here is one of our favorite elements, gold. Gold is an element with the symbol AU. And it is a distinct element all the way down to the atom. And these things that say distinct chemical properties, remember this right up here? Distinct chemical properties. Well, gold has the same properties all the way down to the atomic level. That means a single atom of gold has the same chemical properties as a great big ingot of gold, like what we see here. Distinct from a compound, like one of our favorites, salt. This actually has another name. We call it sodium chloride. And it even has what we call a chemical formula. Sodium chloride, or NaCl. Notice that there is now more than one type of element. That's what we call a compound, which in this case, according to the vast interwebs, is defined as a thing that is composed of two or more separate elements. Okay? Let's ignore this part that says a mixture because we're going to call that something else. Now, what's important to remember about pure substances is that there is no physical way possible to break these down. Let's put that in a place we can look at it. Let's elaborate on this further. Pure substances can't be broken down physically. Elements, well, they can't be broken down at all. They're only one type of atom, and there's no way you can break that down any further. That's it. You can separate them into individual atoms, but you're not going to be able to break them down any further. Compounds, well, these have distinct formulas, like our buddy salt, or table sugar, otherwise known as sucrose, or octane, which is the chemical formula for gasoline, which is how you all get around unless you're riding your horse or driving your Tesla. And so what we want to keep in mind is that these things called compounds can't be separated physically. They're pure substances, and their properties remain intact unless we do something to, for example, say, break up this relationship between the sodium and the chloride ions, which we'll discuss further. All right? So let's go on to what happens when we start to play around with mixing pure substances. We're talking about combining pure substances in a fashion that can be separated physically. We're going to call those mixtures because they're simply occupying the same space. I'll give you a couple of examples here. And what is a better example of a mixture than a delicious chocolate chip cookie? I mean, numbers. What we got going on here is a distinct combination of pure substances. I mean, it's obvious. In fact, let's take a look at a recipe. Look at this. There's a lot going on here. I mean, we've got eggs, we've got vanilla, we've got flour. Oh, there's our buddy salt, and there's our chocolate chips. So this is a good example of a mixture, all right? And you could separate some of these out physically. Some of them would be difficult, but you could go in there with tweezers and bust out some of these chocolate chips if that was your thing. So let's separate these two kinds of mixtures into two different types. Talking about something called a homogeneous mixture. This is a kind of mixture in which different substances are not visible. Here's my favorite example. Gatorade. I mean, when you look at Gatorade, you don't see any different combinations of substances, even though if we look at the ingredients list on Gatorade, let's look at this. There's a lot going on. Here's the ingredients list. And you guys know that the significance of ingredients is the one that's listed first is the most. So Gatorade's mostly water. Then we got sugar, dextrose, citric acid, salt. There's our buddy salt, this guy right here. Then something called sodium citrate, monopotassium phosphate, gum arabic. Boy, those all sound really tasty. And then, of course, this is what gives it its distinctive color. Well, if you're looking at Gatorade, you don't see any of that. So those differences are not visible. But if we're going to contrast that with a heterogeneous mixture, that's a mixture in which the components are visible and very distinct. I'm going to pull up my favorite heterogeneous mixture. You ready? Loaded pepperoni pizza. Now we are talking, because these components are very visible and very distinct and very, very yummy. Woo! So hopefully that paints a better picture. What we're going to do next is get down to the nuts and bolts of how we construct these different elements before we start making them into compounds and mixtures. So I'll see you on the next one.